Math 2, Unit 5, proving theorems about quadrilaterals. And the first quadrilateral we're going to start with is parallelogram. So if you switch over to the third page, worksheet 2, please. Okay? All right. So we're basically going to go through 4 properties of a parallelogram. Okay? And the first property I want you to write down is, in a parallelogram, consecutive angles are supplementary. Okay? In a parallelogram, consecutive angles are supplementary. Remember, consecutive means angles that are next to each other. Okay? So in this case, we have 2 consecutive angles, so they have to be supplementary. So x plus 51 equals 180 degrees. If I subtract 51 from both sides, we get x equals 129. Okay? Any questions on that one? All right. So if we know that this x is 129, can you guys tell me what this angle is? 51, right? And if we know this angle is 51, what is this angle? 129, okay? Which actually takes us down. I'm going to skip down to number 3, okay? Property number 3, which is, in a parallelogram. Thank you. Well, we'll come back to that one. In a parallelogram, opposite angles are congruent. In a parallelogram, opposite angles are congruent. So down here we can say 3a minus 5 equals 40. So we add 5 to both sides and we get 3a equals 45. Divide both sides by 3, we get a equals 15. Questions on that one? Okay. All right, so let's go back up to number 2. Number 1, I forgot to write, what does x equal? 129? All right, number 2. So they give us the sides of the parallelogram, so let's go ahead and write those in. DG is 2x plus 2. DE is 3x plus 1. EF is 3x minus 3. And GF is 2x plus 6. Should always fill out your diagram when you can. All right, which leads us to, in a parallelogram, opposite sides are congruent. In a parallelogram, opposite sides are congruent. So that means that line segment DG is congruent to line segment EF. So we can say that, in this case, 3x minus 3 equals 2x plus 2. If we subtract 2x from both sides, we end up with just x on this side. If we add 3 to both sides, we just end up with 5 on that side, so x equals 5. And we can do the same thing for DE. Should be congruent to GF, which means 3x plus 1 equals 2x plus 6. And again, subtracting 2x from both sides, we end up with just x on the left. If we subtract 1 from both sides, we end up with 5 on the right, just like we expected. If we plug this in, we end up with 12 over here, 12 there, 16 here, and 16 there. So we just kind of not necessarily proved the sides congruent, but we kind of used that property to show that the things can be set equal to each other. Okay, any questions on that one? Okay, I'm not really sure why number 4 is in there, because it's the exact same thing we just did, proving opposite sides are congruent. So we don't need to do number 4. You can just draw an arrow, or you can simply write it again. In a parallelogram, opposite sides are congruent, or draw an arrow from number 2. Whatever you want to do is fine. Which brings us to the last one, which is, in a parallelogram, diagonals are bisected. And what we mean by that is when you draw a diagonal of a parallelogram, remember a diagonal is a line segment from one vertex to any non-adjacent vertex. And in a quadrilateral, you only have 2 diagonals. Okay, one from opposite corners. So what we're saying here is AC is bisected by BD, and BD is bisected by AC. And bisected means cut in half. So if we call this E, we know that AE is congruent to CE, and we know that DB is congruent to, DE, not B, DE, and we know that B is congruent to BE. So you should be able to set those two things apart, or equal to each other, like, for instance, 2x plus 5 equals 11. Solve for x, which is 3, and then use that to solve y plus 4 equals 2x plus 5 by plugging in 3 for x and solving for y.